There are a lot of geometry formulas that are given to you on the SAT. This question does not involve any of the reference ones, though. This is something we kind of need to memorize. It might seem obvious to you, but I don't know. This picture is definitely meant to throw us off our game here. So first of all, you might want to just put the number that they give us on the picture, right? So they tell us angle 1 is 35. So let's put that there. Now, we need to work our way to angle 2, and because we have this magical word parallel, we're going to use this rule about alternate interior angles, basically. So there's a couple ways to look at it. Here's what I see. I see that we have these two lines are parallel, with this line, T, kind of cutting them apart. That's called a transversal. And this is a very common picture if you've taken geometry in school. We see this kind of like bent railroad track thing all the time, and we really need to be able to recognize it. And at least on the SAT, when they tell you that something is parallel for a geometry question, it almost always means that this picture is involved. And so it might be disguised like it is here because there's so much going on, but you want to really make pictures that kind of look like that, you know, bent railroad track, okay? So that means that this angle in here is also 35. So the two alternate interior angles are the two 35s that weren't labeled here. So basically, when we have these parallel lines, we have a lot of congruent angles. So because of vertical angles, this angle 1 and this one here are going to be the same. And then because of alternate interior angles, this other 35 gets thrown into the mix too. And just to complete things, this one is also 35. So then what about all the angles that aren't labeled? Well, because there's 180 degrees on a line, if I were to continue this arc, then I would have 180 degrees. That's a straight line. Those would be considered supplementary angles, and so that we can just get by doing a little subtraction, and that's going to be 145. So here's where now we need to move the 145 over to the 2. You probably see that that's going to be what it is, but technically there are rules involved here, and I want you to know them because it might not be as obvious on a harder version of this question. So now what we need to do is realize, okay, well, if S and T are also parallel, then we can also kind of draw this picture with S and T as the parallel lines and M as the like transversal, which would then mean that because of alternate interior angles, this is also 145, and then because of vertical angles, angle 2 is 145. So it's a lot of like rotating around the picture, but at the end of the day, all we're really doing math-wise is subtracting from 180, finding a pair of supplementary angles. We could have shortened all of this, by the way, by just recognizing that angle 2 is obtuse, meaning it has to be greater than 90 degrees. The picture shows it, that it's bigger than 90, and so the only choice that's bigger than 90 is choice D. Now, the reason that might be a little bit, of a cheat here is that on other versions of this question, it might not work. So if we have a picture on the SAT, we can assume that the picture is drawn to scale, unless it has that little note underneath that says, figure not drawn to scale. Sometimes that note is there, so you got to pay attention to it. If it's not there, then the picture should be to scale, and you might be able to eliminate some answers just by, eyeballing it. But if they do say it's not drawn to scale, then the picture, anything goes. We can't trust it. Hopefully this was a nice little review of this rule. The gist of it, like I said, is you want to find this picture wherever they say that lines are parallel, right? So anytime lines are parallel, you're going to have a lot of angles that end up being equal. That's what they're testing here. There's lots of ways that they can disguise this picture, but that word parallel should not be ignored. It is an important word in most questions in which it appears, and it's probably the key to solving that question. So pay attention to it.